Hello everyone, my name is Narat Singh Rawat from Badlia College. I am pursuing my BTech from Computer Science Engineering and I am today presenting my presentation architecture and reference model. Okay, so let's begin. So first start with introduction. The IoT is a support infrastructure for enabling objects and places in the physical world to have a corresponding representation in the digital world. The devices are physically artifacts with which the physical and virtual world interact. An ARM consists of two main parts, a reference model and a reference architecture. So now representing a reference model. The IoT reference model aims at establishing a common grounding and a common language for IoT architecture and IoT system. Basically, reference model presents a ground for a common ground to interact all the techniques. The model describes how tasks at each level should be handled to maintain simplicity, allow high scalability, and ensure supportability. Finally, the model defines the functions required for an IoT system to be completed. Network compute, application, and data management architectures that are IoT ready requires a different communication and a processing model. Today, there is not a standard way of understanding or describing these models for IoT. The purpose IoT reference model is comprised of 7 levels. Each level is defined with terminology that can be standardized to create a globally accepted frame of reference. IoT reference model comprises domain model, information model, communication model, and disclosure. General concerns. Domain model is in top level, information model is in knowledge, and communication model comes under behavior, as you can see in this diagram. Okay, so move next. There are the 7 levels as I mentioned before. First level is physical device and controller, second connectivity, third edge computing, fourth data accumulation, fifth data abstraction, application, collaboration, and process. Now we will describe these levels. Physical device and controllers. The IoT reference model start with level 1, physical device and controllers that might control multiple devices. Second stage, connectivity. Communication and connectivity are connected is in one level to level 2. The most important function of level 2 is reliable, timely information transmissions. Edge computing, इसको फॉग भी कहते हैं. The function of level 3 are driven by the need to convert network data flows into information that is suitable for storage and higher level processing at level 4. Data accumulation. Level 4, data accumulation. Data accumulation, data in motion is converted to data at rest. Applications typically assume that data is at rest or unchanging in memory or on disk. Fifth, data abstraction level. It is focused on rendering data and its storage in ways that enable developing simpler performance and enhance application. Fifth layer is application layer, where information interpretation occurs. Seventh layer is collaboration process layer. IoT includes people and processes. The IoT system and the information it creates is of little value unless it yields action, which often requires people and processes. People use application and associated data for their specific needs. Often multiple people use the same application for a range of different purposes. So the objective is not the application. It is to empower people to do their work better. Reference architecture. It provides a starting point for architects looking to create IoT situation as well as a strong basic for further developments. The reference architecture must cover multiple aspects including the cloud or server side architecture that allow us to monitor, manage, interact with and process the data from the IoT devices. The networking model to communicate with the devices. Reference architecture. We can summarize the overall requirements into some key categories: connectivity and communication, device management, data collection, analysis and acquisition, scalability, security, HA, predictive analysis, integrations. Now study about REST. REST is stand for representational state transfer. What is representational state transfer? REST is a software architecture style that defines a set of constraints to be used for creating web services. Web services that conform to the REST architecture style called RESTful web services provide interpretability between computer systems on the internet. RESTful system aim for fast performance, reliability, and the ability to grow by reusing components that can be managed and updated without affecting the system as a whole, even while it is running. To understand the REST principle, look at what happens in a web access to a browser. Look at the diagram. Okay, now understand the steps. First, the client references a web resource using a URL. The web server returns a representation of the resources in the form of an HTML document. Then this resource places the client into a new state. The user clicks on a link in the resource, example a document or any HTML files, which results in another resources access. The new resources places the client in a new state. The client application changes state with each resource representation. Example of REST services, there are given 5 examples. There are many more. 5 of them are Amazon S3, Atom Publishing Protocol, Flickr API, Yahoo Web Search, DYN, DNS, IP addresses, etc. Uniform Resource Identifiers. Definitions about URI. A URI is a string of characters that unambiguously identifies a particular resources. Okay. To guarantee uniformly, all URI follows a predefined set of syntax rules, but also maintain extensibility through a separately defined hierarchical naming scheme. Uniform resource name. It is a URI that identifies a resource by name in a particular namespace. Example is given is 0-486-27557-4. Uniform resources locator. It is a URL that specifies the means of acting upon or obtaining the representation of a resources, either specifying both its primary access mechanism and network location. Example is given about wiki websites. Example. Challenges in IoT. First challenge is about stability of network. Developing IoT product in network unstable. Example, poor GSM GPRS signal environment creates issue about this. Okay, factor which creates this challenge are link speed, link stability, software state machine, asynchronous condition, resolutions, boundary value tuning, algorithm enhancement, dynamic detection. I did all three challenges, factors and resolution for all each challenges. So let's move next. Challenge number 2, power management. Overall power consumptions by sensory nodes in IoT should be minimal, should consider functional as well. Okay, factors of these are minimalistic power need, higher power backup, power fluctuations, power failure recovery, etc. Resolutions, component selection, HW Turing. HW means software Turing. Next challenge in our domain is network failover and memory management. Challenge: during management failover, internal non-volatile memory should store critical data. Factors about these are network outage, fleet management, optimization or cost implementation, resolution, decision making in NVM, choosing right memory and data structure, NOR, NOR instead of NAND. These are gates. Creating secondary partitions for failover handling. Next, operating system optimization and tuning. In case of IoT devices running OS, example is embedded Linux is running in OS. Optimizing and tuning provides challenges. Open source uses, unsupported peripherals, size requirements, performance requirements are the factors of these challenges. Resolutions are what we can do are custom device drivers, open source size reductions techniques, tuning kernel subsystems. Non-functional requirements. Non-functional requirements puts up on a lot of challenges during design phase. Product casing, form factor, EMI, regulatory requirements are the factors of these challenges. What we can do? What are the resolutions? There are some given: industrial standards, good shielding, component selection standards, and security protocol, etc. IoT is a large technique, and there is a lot of things which is remain to research. That's why there is a very challenges in security. Some of them I have introduced you before, and some of them I mentioned here, which you can understand without descriptions. First is IoT data security and privacy issues. Privacy means your data is used. IoT update risk when whenever you have to any time you have to connect with the network. Malware and ransomware attack on IoT. The problem with default password, small IoT attacks that evade detection, AI and automation, home invention, untrustworthy communication, etc. Many more. Okay. Thank you everyone.